Good morning. In our last class, we were discussing the synopsis part of the chapter atoms, and we have covered up to Rutherford's atom model. We have discussed what are the success and what are the failures of Rutherford's atom model. We will now continue the synopsis from distance of closest approach. See, we have already come across this term, distance of closest approach. We know that whenever an alpha particle starts moving towards the nucleus, because the alpha particle is positively charged and the nucleus is also positively charged, there will be a force of repulsion between them. As the alpha particle starts moving towards the nucleus, the kinetic energy of the alpha particle goes on decreasing, or we can also say the velocity of the alpha particle goes on decreasing because of the repulsive force exerted by the nucleus. See, alpha particle is positively charged and nucleus is also positively charged, so there must be force of repulsion between them. Once the alpha particle is projected towards the nucleus, its velocity goes on decreasing, and at one point, the velocity of the alpha particle becomes zero. At this point, the velocity of the alpha particle becomes zero, or we can also say at this point, the kinetic energy of the alpha particle becomes zero. The distance between this point where velocity of the alpha particle becomes zero and the central line of the nucleus, the distance between the point where velocity of alpha particle becomes zero and the central line of the nucleus is called as distance of closest approach. So distance of closest approach is defined as the distance between central line of the nucleus and the point where velocity of alpha particle becomes zero. See, once the alpha particle comes to rest at this point, immediately the alpha particle retraces its path. At this point, alpha particle momentarily comes to rest, and from this point, alpha particle retraces its path because of the repulsive force exerted by the nucleus. Right? So it doesn't come to rest at this point, or it doesn't stop at this point. Its velocity becomes zero at this point for an instant, and immediately the alpha particle retraces its path. This is the idea of distance of closest approach, and distance of closest approach is represented by R naught. See, when the alpha particle is projected towards the nucleus, what happens is all its kinetic energy starts getting converted into the potential energy of the system of these two particles. At this point, the kinetic energy of the alpha particle becomes zero. Andre e point hatra alpha particle the complete kinetic energy potential energy ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗಿಬಿಡುತ್ತದೆ. So the complete kinetic energy of the alpha particle would get converted into potential energy of system of two charges. See, which are the two charges here? Alpha particle and the nucleus. The charge on alpha particle is plus 2e, whereas the charge on the nucleus is plus Ze, where Z represents atomic number. You must know how to write charge on a nucleus. See, we know only protons and neutrons are present in the nucleus. In nucleus, there are only protons and neutrons. Neutrons does not have any charge. So, the charge contribution of nucleus is only because of the protons. We know charge on each proton is plus 1e, charge on one proton is plus 1e, charge on two protons will be plus 2e, charge on three protons will be plus 3e, and so on. And charge on Z protons will be plus Ze. If there are Z protons in a nucleus, the charge on that nucleus will be plus Ze. Z represents atomic number, right? So all the kinetic energy of the alpha particle will get converted into potential energy of system of alpha particle and the nucleus. See, these two form a system of two charges, right? So adun illi madin nanu all kinetic energy of alpha particle gets converted into potential energy. Kinetic energy is equal to, we know potential energy of system of two charges. Now ಮಾಡಿವಿ electrostatics nage 1 by 4 pi epsilon naught q1 q2 by r. q1 is nucleus Ze, q2 is alpha particle plus 2e divided by distance between them is r naught. So kinetic energy of alpha particle is equal to 1 by 4 pi epsilon naught Ze into 2e divided by r naught. This becomes ನಮಗೆ ಬೇಕಾಗಿರೋದು ಆರ್ ನಾಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ಕ್ಲೋಸೆಸ್ಟ್ ಅಪ್ರೋಚ್. ಈ ಆರ್ ನಾಟ್ ಈ ಕಡೆ ಹಾಕಿ ಬಿಕಮ್ಸ್ 1 by 4 pi epsilon naught 2Ze square divided by kinetic energy of alpha particle. This is the expression for distance of closest approach. So distance of closest approach is given by 1 by 4 pi epsilon naught 2 z e square divided by kinetic energy of alpha particle. If you want, you can express this kinetic energy of alpha particle as half mv alpha square, half mv alpha square. V alpha is velocity of alpha particle, right? So using this formula, you can calculate distance of closest approach. So at a distance of closest approach, what is to be remembered is all the kinetic energy of alpha particle gets converted into potential energy of system of two charges. The two charges involved here are nucleus and the alpha particle. We know the potential energy of system of two charges. It will be 1 by 4 pi epsilon q1 q2 divided by r. q1 is charge on nucleus, that is, q2 is charge on alpha particle, 2e, and distance between nucleus and the alpha particle at distance of closest approach is r naught. So 1 by 4 pi epsilon z into 2e divided by r naught ಆಗ್ತದೆ. ನಮಗೆ r naught ಬೇಕಾಗಿರೋದ್ರಿಂದ r naught ನ LHS ಶಿಫ್ಟ್ ಮಾಡ್ರಿ, kinetic energy denominator ಶಿಫ್ಟ್ ಆಗ್ತದೆ. 1 by 4 pi epsilon 2 z e square divided by kinetic energy of alpha particle. This is the expression for distance of closest approach. After understanding what is distance of closest approach, you should also know what is impact parameter. See, impact parameter is defined as the perpendicular distance between initial velocity vector of alpha particle and the central line of the nucleus. See, initially the alpha particle is projected in this direction. So this is the initial velocity vector of the alpha particle. Once this alpha particle comes close to the nucleus, because of the repulsive force exerted by the nucleus on alpha particle, the direction of velocity of alpha particle changes. ಯಾವಾಗ ಆಲ್ಫಾ ಪಾರ್ಟಿಕಲ್ ನ್ಯೂಕ್ಲಿಯಸ್ಗೆ ಹತ್ರ ಬರ್ತದೋ ಅವಾಗ ಆಲ್ಫಾ ಪಾರ್ಟಿಕಲ್ದು ವೆಲಾಸಿಟಿ ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಆಗ್ತದೆ. ಬಟ್ ಇಂಪ್ಯಾಕ್ಟ್ ಪ್ಯಾರಾಮೀಟರ್ನಾಗ ಏನು ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ, ವಿ ಹ್ಯಾವ್ ಟು ಮೆಷರ್ ದ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಇನಿಷಿಯಲ್ ವೆಲಾಸಿಟಿ ವೆಕ್ಟರ್ ಆಫ್ ದ ಆಲ್ಫಾ ಪಾರ್ಟಿಕಲ್ ಅಂಡ್ ದ ಸೆಂಟ್ರಲ್ ಲೈನ್ ಆಫ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್. This perpendicular distance between initial velocity vector of the alpha particle and the central line of the nucleus is called as impact parameter. Suppose if the alpha particle starts coming close to the central line of the nucleus, impact parameter goes on decreasing, and during head-on collision, that means when alpha particle is projected directly towards the nucleus, we call such collisions as head-on collision. Ignore it, there is some perpendicular distance between central line of nucleus and the alpha particle. When alpha particle starts coming close to the nucleus, impact parameter goes on decreasing, and once the alpha particle starts moving directly towards the nucleus, impact parameter becomes 0. So impact parameter is 0 during head-on collision. Impact parameter is given by z e square cot theta by 2. Theta is angle of scattering. ನೋಡ್ರಿ, ಈ ಒರಿಜಿನಲ್ ಡೈರೆಕ್ಷನ್ ಆಫ್ ವೆಲಾಸಿಟಿ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ರಿ, ಇದು ಎಷ್ಟು ಡಿವೈಟ್ ಆಗ್ತದೆ ಆಂಗಲ್ ಗೊತ್ತಾಗ್ತದೆ. So theta is angle of scattering divided by 4 pi epsilon naught kinetic energy of alpha particle. Z is square cot theta by 2 divided by 4 pi epsilon naught kinetic energy of alpha particle. If you want, you can write this as half mv alpha square. Kinetic energy can be written as half mv alpha square if the problem demands it. Now, here I have shown you the case of head-on collision. Alpha particle is moving directly towards the nucleus. When alpha particle moves directly towards the nucleus, at some point, kinetic energy of the alpha particle becomes 0, and at this point, the alpha particle starts retracing its path. Hagadre alpha particle ಎಷ್ಟು angle scattering at nodri. Alpha particle was moving along straight line, and because of repulsive force exerted by the nucleus, alpha particle retraces its path. So the angle of scattering in this case is 180 degrees. So angle of scattering here is 180 degree. So if you substitute this 180 here, it becomes cot 180 by 2. 180 by 2 is 90. So z is square cot 90 divided by 4 pi epsilon naught kinetic energy of alpha particle. We know that cot 90 is 0. So 0 into anything will be 0. So during head-on collision, impact parameter will be minimum 0. Right? So this is regarding the idea of impact parameter. Once we understand what are the distance of closest approach and impact parameter, we need to understand Bose atom model. This is one of the most important atom models. ಇಲ್ಲಿಂದ ನಮಗೆ ಪ್ರಾಬ್ಲಮ್ಸ್ MCQs ಕೂಡ ಬಹಳ ಬರ್ತವೆ. So try to concentrate on Bose atom model. See, Bose atom model is a small extension of Rutherford's atom model. more number of points are retained as it is from Rutherford's atom model. ಇಲ್ಲಿ ಬಹಳ ಜಾಸ್ತಿ changes ಆಗಿಲ್ಲ. There are very slight changes in Bohr's atom model. According to Bohr, electrons, according to Rutherford, if you look at Rutherford's atom model, Rutherford says an electron revolves around the nucleus in circular orbit. He says, Rutherford says, electron revolves around the nucleus in all possible circular orbits. ಯಾವ circular orbits possible ಅದ್ರಾಗ ಎಲ್ಲ electron ತಿರುಗಬಹುದು ಅಂತ Rutherford ಹೇಳ್ತಾನೆ. But if this happens, if an electron can revolve in all possible orbits, then according to classical electromagnetic theory ಅಂತದೆ, ಅಲ್ಲಿ ಏನು ಹೇಳ್ತಾರೆ ಅಂತಂದ್ರೆ, whenever an charged particle is accelerated, it emits energy in the form of light ಅಂತ ಹೇಳ್ತಾರೆ. See, electron is revolving around the nucleus. We know that electron is a charged particle. Electron is negatively charged particle. If it is revolving around the nucleus, it must be acted upon by centripetal force. ಒಂದು ಪಾರ್ಟಿಕಲ್ ಸುತ್ತಬೇಕು ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ನಾಗೆ ಅಂತಂದ್ರೆ ಅದಕ್ಕೆ ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್ ಬೇಕು. We know centripetal force for electron to revolve around the nucleus is provided by electrostatic force between nucleus and the electron. The electrostatic force between nucleus and the electron provides necessary centripetal force for the electron to revolve around the nucleus. Hagadri, if centripetal force is acting on the electron, electron also has centripetal acceleration. Yav particle mel force irtado, aa particle mel acceleration irtade. So electron has centripetal acceleration. Hagadri, electron is a charged particle and it has acceleration. According to classical electromagnetic theory, an accelerated charged particle should continuously emit energy in the form of electromagnetic radiation. Hagadri, electron orbit na suttbekadaga it is accelerating, so it must be continuously emitting energy. Andre ee electron energy continuously decrease ಆಗ್ತಾ ಬರ್ತದೆ. As a result, the electron starts revolving in circular orbits of smaller and smaller radius. ಇದೇ ಆರ್ಬಿಟ್ ನ ಕಂಟಿನ್ಯೂ ಮಾಡಲ್ಲ electron. Electron doesn't continue to revolve in the same orbit. Instead, electron starts revolving in orbits of smaller and smaller radius because its energy is continuously decreasing and eventually falls into the nucleus. Once the electron falls into the nucleus, it means the destruction of atomic structure. Atomic structure destroy ಆಗಿಬಿಡುತ್ತೆ. Rutherford atom ಹಿಂಗಿರ್ತದೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟಿದ್ದ. Electrons can revolve in all possible orbits ಅಂತ ಹೇಳಿದ್ದ Rutherford. If electron revolves in all possible orbits, it must continuously radiate energy and follow spiral path and eventually fall into the nucleus, and that means the destruction of atomic structure. Andre Rutherford's proposed atom model is not stable. Rutherford could not account for stability of an atom, so Bohr came up with a different idea. Bohr said electrons revolve around the nucleus, that's true, but electrons cannot revolve around the nucleus in all possible orbits. ಎಲ್ಲ ಆರ್ಬಿಟ್ಸ್ ನಾಗೂ ಎಲೆಕ್ಟ್ರಾನ್ ತಿರುಗಂಗಿಲ್ಲ ಅಂತ ಹೇಳ್ದ. Instead, electrons can revolve around the nucleus only in certain permitted orbits called as stationary orbits. Bohr introduced the idea of stationary orbits. This is most important. So electrons do not revolve in all possible orbits as said by Rutherford. Instead, electrons can revolve around the nucleus only in certain permitted orbits called as stationary orbits. In these stationary orbits, electrons do not radiate any energy. If this were a stationary orbit, electron will not lose any energy in the stationary orbit, and so it continues to revolve in the same orbit. Electron doesn't follow spiral path and fall into the nucleus. Atom stable ಆಗಿಬಿಡ್ತದೆ ಇವಾಗ. ಈ stationary orbits idea introduce ಮಾಡಿರೋದ್ರಿಂದ Bohr could account for stability of the atom. So electrons revolve around the nucleus only in certain permitted orbits called as stationary orbits. In stationary orbits, electrons do not radiate any energy. ಈಗ ಹಾಗಾದ್ರೆ which orbits should be called as stationary orbits? ಈಗ ಎಲೆಕ್ಟ್ರಾನ್ ಸುತ್ತ ಈ ನ್ಯೂಕ್ಲಿಯಸ್ ಸುತ್ತ ಬೇಕಾದಷ್ಟು ಆರ್ಬಿಟ್ಸ್ ಅವೆ, ಯಾವುದನ್ನ ಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್ ಅಂತ ತಗೋಬೇಕು ಅಂತ ಬೋರ್ ಹೇಳ್ತಾರೆ. ಅಕಾರ್ಡಿಂಗ್ ಟು ಬೋರ್, angular momentum of electrons in stationary orbit is an integer multiple of h/2π. ಯಾವ ಆರ್ಬಿಟ್ ನಾಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ಆಂಗ್ಯುಲರ್ ಮೊಮೆಂಟಮ್ ಇಂಟೀಜರ್ ಮಲ್ಟಿಪಲ್ ಆಫ್ h/2π ಇರ್ತದೋ ಆರ್ಬಿಟ್ ನ ಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್ ಅಂತ ಕರಿಬೇಕು ಅಂತ ಹೇಳ್ತಾರೆ. So stationary orbits are those orbits in which angular momentum of electron is an integer multiple of h/2π, right? So angular momentum is represented by mvr, where m is mass of electron, v is velocity of electron, and radius r is radius of electron orbit. R is radius of electron orbit. mvr represents angular momentum, angular momentum of electron in a stationary orbit should be n into h by 2 pi, where n represents an integer 1, 2, 3, 4. Actually, n represents principal quantum number, and we know principal quantum number are integers, right? Starting from 1 and ending to infinity. Zero error, principal quantum number cannot take zero value. So n should start from 1. So angular momentum of an electron in stationary orbit is an integral multiple of h by 2 pi, where h is Planck's constant. H is Planck's constant, right? So this is the second possibility. Hagadre, what will be the angular momentum of electron in first orbit anta keltare. For first orbit, principal quantum number will be 1, n will be 1. Hagadre mvr is equals to 1 into h by 2 pi, h by 2 pi. For second orbit, n will be equal to 2. So angular momentum of electron in second orbit must be 2h by 2 pi. N is 2, 2 into h by 2 pi. 2 and 2 gets cancelled out, you will be left out with h by pi, and so on. Third orbit na kelidre 3h by 2 pi. Fourth orbit na electron angular momentum kelidre 4h by 2 pi, so on. So electrons or angular momentum of an electron is quantized. We say angular momentum of an electron is quantized. Angular momentum of electron cannot take any arbitrary values. Angular momentum of electron may be 1h by 2 pi. Angular momentum of electron may be 2h by 2 pi. Angular momentum of electron may be 3h by 2 pi, 4h by 2 pi, 3.5h by 2 pi, 3.6h by 2 pi, 2.1h by 2 pi are not possible. Only definite values of angular momentum of electron are possible in its orbit, right? So ಯಾವ ಆರ್ಬಿಟ್ ನ ಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್ ಅಂತ ಕರಿಬೇಕು ಅಂತಂದ್ರೆ, ಯಾವ ಆರ್ಬಿಟ್ ನಾಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ಆಂಗ್ಯುಲರ್ ಮೊಮೆಂಟಮ್ ಇಂಟೀಜರ್ ಮಲ್ಟಿಪಲ್ ಆಫ್ h by 2 pi ಇರ್ತದೋ ಆ ಆರ್ಬಿಟ್ ನ ಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್ ಅಂತ ಕರಿಬೇಕು, right? And then Bohr also accounts for when the radiation is emitted. See, according to Bohr, when an electron makes transition from higher orbit to a lower orbit, when electron jumps from higher orbit to a lower orbit, it emits energy in the form of light. Iga Rutherford model nagadre, he said that electron revolves in all possible orbits. So during its revolution around the nucleus, electron will be continuously losing the energy. Because of it, electron follows spiral path and eventually falls into the nucleus. This was the theory regarding energy emission in Rutherford's model. Bohr's model nage energy emission theory bare ade. He says electrons can revolve only in certain permitted orbits called as stationary orbits. Stationary orbit nage electron energy emit ಮಾಡಲ್ಲ. ಹಾಗಾದ್ರೆ electron energy ಯಾವಾಗ emit ಮಾಡ್ತದೆ ಅದನ್ನ ಹೇಳ್ತಾನೆ Bohr. An electron emits energy only when it makes transition from a higher orbit to a lower orbit. ಯಾವಾಗ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಹೈಯರ್ ಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್ ಇಂದ ಲೋವರ್ ಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್ ಜಂಪ್ ಆಗ್ತದೋ ಆವಾಗ ಮಾತ್ರ ಎನರ್ಜಿ ಎಮಿಟ್ ಆಗ್ತದೆ ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊ ಎನರ್ಜಿ ವಿಲ್ ಬಿ ಎಮಿಟೆಡ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಫೋಟಾನ್. ಫೋಟಾನ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಲೈಟ್. ಫೋಟಾನ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಲೈಟ್. ವಾಟ್ ವಿಲ್ ಬಿ ದ ಎನರ್ಜಿ ಆಫ್ ಫೋಟಾನ್ ಅಂತಂದ್ರೆ, ಎನರ್ಜಿ ಆಫ್ ಫೋಟಾನ್ ಎಮಿಟ್ ಆಗಿರೋ ಫೋಟಾನ್ ಎನರ್ಜಿ ಎಷ್ಟಿರ್ತದೆ ಅಂತಂದ್ರೆ E2 minus E1 is equals to h nu, right? This is actually the energy of photon. We know that energy of photon is h nu. ಎಷ್ಟಿರ್ತದೆ ಇದು? ವಾಟ್ ವಿಲ್ ಬಿ ದ ಎನರ್ಜಿ ಆಫ್ ಫೋಟಾನ್? ವಾಟ್ ವಿಲ್ ಬಿ h nu equal to ಅಂತಂದ್ರೆ, h nu will be equal to difference in energies of electron in the two orbits. ಸೆಕೆಂಡ್ ಆರ್ಬಿಟ್ ಅಥವಾ ಹೈಯರ್ ಆರ್ಬಿಟ್ ನಾಗ ಎಲೆಕ್ಟ್ರಾನ್ ಎನರ್ಜಿ ಎಷ್ಟಿತ್ತು, ಲೋವರ್ ಆರ್ಬಿಟ್ ನಾಗ ಎಲೆಕ್ಟ್ರಾನ್ ಎನರ್ಜಿ ಎಷ್ಟದೆ, ಅವೆರಡನ್ನು ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿದ್ರೆ ಯು ವಿಲ್ ಗೆಟ್ ದ ಎನರ್ಜಿ ಆಫ್ ದ ಫೋಟಾನ್ ಎಮಿಟೆಡ್. If the energy of the electron in the second orbit is say 10.2 electron volt, and the energy of the electron in the first orbit is say 13.2 electron volt, energy emitted will be about 3.4 electron, something like that, right? Actually our negative irtave, we will calculate, but the energy emitted or energy of the photon emitted is given by E2 minus E1 is equals to h nu, where E2 represents energy of the electron in the second orbit. Second orbit na electron energy estu annadu E2, first orbit na electron energy estu annadu E1, right? So this is the expression for energy of the photon emitted. After this, you need to know what is Bohr's frequency condition. We know that E2 minus, whenever electron makes transition from higher orbit to a lower orbit, the energy of the photon emitted is given by E2 minus E1 is equals to h nu, where h is called Planck's constant and mu is called frequency of the radiation emitted. ಇಲ್ಲಿ ಏನು ಫೋಟಾನ್ ಎಮಿಟ್ ಆಗ್ತದಲ್ಲ, ಆ ಫೋಟಾನ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಕ್ಚುಲಿ ಲೈಟ್ ಪ್ರಾಪಗೇಷನ್ ಆಗಿದ್ದಾಗ ಇಟ್ ಬಿಹೇವ್ಸ್ ಲೈಕ್ ವೇವ್. So we can associate frequency to it. So nu is the frequency of the photon emitted ಅಂತ ಹೇಳ್ತೀವಿ. So nu can be written as E2 minus E1 divided by H. This is called as Bose frequency condition. Nu is equals to E2 minus E1 divided by H. Also, we know that C is equals to nu lambda, speed of light is equals to frequency into wavelength, C is equals to nu lambda. So, nu can be written as C by lambda. Nu can be written as C by lambda. So, in place of nu, you can substitute C by lambda. C by lambda is equals to E2 minus E1 by H. ಈ C ನ ಕೆಳಗೆ ಕಳಿಸ್ಬಿಡ್ರಿ 1 by lambda is equals to E2 minus E1 divided by HC. ಇಲ್ಲಿಂದ you can calculate wavelength of the light emitted. Frequency of the light emitted can be calculated using nu is equals to E2 minus E1 by H. Wavelength of the light emitted can be calculated using the formula 1 by lambda is equals to E2 minus E1 divided by HC. ಅಥವಾ ನಿಮಗೆ ಡೈರೆಕ್ಟ್ ವೇವ್ಲೆಂತ್ ಬೇಕಂದ್ರೆ ಇದನ್ನು ರೆಸಿಪ್ರೊಕೇಟ್ ಮಾಡ್ರಿ. ಲ್ಯಾಂಬ್ಡಾ is equals to HC by E2 minus E1 ಆಗ್ತದೆ. So these are some of the important formulae on which numericals may be asked, MCQs may be asked. So try going into this material. In the next class, we will study about the expression for radius of electron orbit. We'll study about Bohr radius. We'll study about total energy of electron in the nth orbit of hydrogen atom. Total energy, sum of kinetic and potential energies. What will be the kinetic energy? What will be the potential energy of the electron in an orbit? What is the relationship between kinetic energy and potential energy? Right? That we will study in our next class. Thank you.